Okay, this is section 10.1 and 10.2. So we're going to be using slope to identify quadrilaterals, okay, on the coordinate plane. So that's our learning target here for this section, okay? So we're going to use the slope and how it relates to parallel lines. And we're going to also use the slope and see how it relates to perpendicular lines, okay? In order to figure out if a quadrilateral is, for example, a parallelogram, or if a quadrilateral is a rectangle, or if a quadrilateral is a rhombus, etc. So let's review a little bit the idea of slope here. So remember that the variable we use for slope is m, okay? And m is the changing y over the changing x, okay? Which is the rise over run, okay? So when you think of slope, you want to think of rise over run. And the way we figure out the rise is by doing y2 minus y1, right? That's the little formula. And then over x2 minus x1. Okay, so if we have 2 points, 2 sets of points, we are able to find the slope by using this formula here. So let's see how we can find the slope graphically, right? So I have this line, okay, that's on this coordinate plane, and I want to figure out the slope of the line. Okay, so the first thing you need to do is you need to find 2 points that are on a perfect corner. Okay, it has to be exactly on a perfect corner where the grid meets. It can't be in the middle, otherwise those points don't count. Okay, so I found these 2 points that were exactly on the corner. Now I can draw a little triangle and I can figure out what is the rise and what's the run, okay, of from one point to the next. So I always start from left to right, okay? So in this case, I'm going up 1, 2, 3. So that's my rise is 3. And then I'm going over to the right 1. So that means my run is 1, okay? So the slope here is 3 over 1 or 3. Okay, notice that when I go from left to right, if I go up, that means the slope is positive. And if I go down from left to right, that means my slope is negative, okay? So in order to find, so that's how you would find it graphically, okay? Figure out the rise and then the run. Now, if I have 2 points, okay? If I have 2 points, then I have to plug into the little formula above right here. So m equals y2 minus y1 over x2 minus x1. Another option is to use a little table, okay? And then figure out the change. Okay, so if I build this little table right here, okay, x, y, I can just put my points on the table. So 3, 5, 3, 5, and then the other point is 6, 7. So now I figure out, okay, what's 6 take away 3? So 6 take away 3 is going to give me 3. So that's the change from 3 to 6. Then I figure out, okay, what's 7 take away 5? So that's 2. So that means my changing y is 2. Now I just put it as a fraction, rise over run. So the y's go on top, and then the x goes on the bottom. So it's 2 over 3. So the slope of this line is 2/3. If I put it in the formula, same idea. You just plug it in. Y2 minus y1, so that's 7 minus 5, over x2 minus x1, so that's 6 minus 3. And that's equals to 2/3. Okay, so either way you decide to do it, you're going to end up with the same answer. Okay, here's another example, okay, for finding the slope. The point is 5, -2, so I put that on the table. 3, -2, I put it on the table, so I figure out what's the change here from 3, so let's see, 3 minus 5 is going to give me a -2. And then -2 minus a -2, it's going to be -2 plus 2, which ends up being 0. So that means my slope is 0 over -2, which is 0. Now let's take a look at the equations of the line. So I have 3 equations, okay, 3 general forms. The slope-intercept form, y equals mx plus b. Point slope form, y minus y1 equals m times x minus x1. And the standard form, ax plus by plus c. So a lot of the problems is going to involve you is going to require you to change from standard form to slope intercept form. Okay, so these couple of problems is just a little practice for you. So usually when it's in standard form, the first thing you would want to do is subtract the x term from both sides. In this case, I subtract 3x, and I get negative 2y equals negative 3x minus 16. Remember that the negative 16 and the negative 3x, they're not like terms, so I can't combine them. So I just list them side by side. Now I divide everything by negative 2. So I divide this term by negative 2, I divide this term by negative 2, and I divide this term by negative 2. And then I simplify, I cleaned it up. These cancels, I ended up with y equals. This is a negative divided by a negative, it's going to be positive, 3 over 2x. And then a negative divided by a negative is going to be positive, so it's plus 16 divided by 2 is 8. Okay, so that's my answer right there. Same thing with this one. I subtract the x term from both sides. I end up with negative 8y equals negative 11x minus 48. Again, I can't combine these terms, so I have to list them separately. Divide everything by negative 8, and then clean it up. So I have y equals 11 over 8x plus 6. Let's take a look at finding the equation of a line in slope-intercept form that connects 2 points. So the first thing you need to be able to do here is to find the slope of the line. Once you find the slope of the line, you plug it in to the equation y equals mx plus b, okay? And then you solve for b, okay? And then you just put it back in the equation, m and b. So let's see this example here. So I want to find the equation of the line that goes through the points 3, negative 1, 6, negative 3. So again, to find the slope, you can either use the formula like I did here, or you can do the little table like I showed you above. So you can do the little table and find the slope as well. Okay, so I did negative 3 minus a negative 1 right here over 6 minus 3. So negative 3 plus 1 is negative 2. And then 6 minus 3 is 3. So my slope here is negative 2/3. Now that I have the slope, I'm going to pick one of these 2 points to use to find the equation of the line. I'm going to use 3 comma negative 1. That's the one I pick right here. So now I'm going to plug it into y equals mx plus b. Y, which is negative 1, equals m, which is negative 2/3, times x, which is 3, plus b. Okay? So now here what's going to happen is this is the same as 3 over 1. And then I can cancel out the 3's here. Or you could do negative 2 times 3, which is negative 6. And then negative 6 divided by 3, it's going to give you negative 2. Okay, so either way, you're going to end up with a negative 2 there. So I have negative 1 equals negative 2 plus b. When I add 2 to both sides, I end up with b equals 1. Now you just plug the values back in. So we're going to plug in b, which is 1, and we're going to plug in m, which is negative 2/3. The y and the x stays the same. Okay, so that's the equation of the line in slope-intercept form. So what I would like you to do is to take a minute and complete the 2 problems that are underneath this one, okay, before moving on. Okay, so you want to practice the same types of problems right now before you move on. All right, now let's try to understand slope a little bit, right? So 2 non-vertical lines are parallel if and only if they have the same slope, okay? So if and only if is a statement that goes back and forth, okay? So for example, I can start with 2 lines that have the same slope. If I know 2 lines have the same slope, it means that they are parallel, or the other way around. If 2 lines are parallel, then I know they have the same slope, okay? So those are interchangeable like that. So let's see. So graphically, right? If I take a look at the rise over run, okay, graphically, Remember, you find 2 points on an exact corner. Now notice that I use this point and this point. I could not use this point right here in the middle because see, this is not on an exact corner of the grid. I couldn't use this point. It's not on an exact corner of the grid. I could use this one. This one is on an exact corner, you see, of the grid, where the grid crosses. Okay, so that's an important part here. So now if I take the slope of this line, I rise 1 and I go over 2. So the slope here is 1 over 2. If I check the other line, the rise is 1 and the run is 2. So that's 1 over 2. So I compare the slopes. Okay, 1/2, 1/2. That means that the slopes are the same, which means the lines are parallel. Okay, and remember, all vertical lines are going to be parallel. Okay, so now let's take a look at perpendicular lines. In a coordinate plane, 2 non-vertical lines are perpendicular. Remember, this the upside down T means perpendicular. If and only if, so this IFF means if and only if, the product of their slopes is -1. Okay, so what does that mean? Okay, if I have 2 lines and one of them the slope is 1/2 and the other one the slope is -2. If I multiply a 1/2 with a -2, I need to get -1 in order to know that those lines are perpendicular. So let's look over here. I did the work right here. So 1 over 2 times -2. So this is the same as -2 over 1. I do 1 times -2, which is -2. On the bottom, I do 2 times 1, which is 2. -2 divided by 2 is going to give me a -1. So that means these lines are perpendicular. Okay? And how did I find the slope? Graphically? Well, I looked for the line. I looked for 2 perfect corners. I drew the points, and I found out my rise and my run, and I wrote it as a fraction, rise over run. Same with this one. This one, the slope is negative because it's going down from left to right. So it goes down 1, 2, and then over to the right 1. Okay, so these 2 lines are perpendicular. This is a very important section, guys. You need to make sure you understand slope, how to find the slope, how to identify parallel and perpendicular lines, okay? And how to write the equation of the line. Okay, so parallel lines have the same slope. Perpendicular lines have opposite reciprocal slope, okay? I would like for you to take a moment and try these problems that are right here. So we know the line P passes through these 2 points. Line B passes through these 2 points. So you want to verify that these lines are parallel. Well, parallel lines have the same slope. So what you have to do here is you have to find the slope of this line, line P. Then you have to find the slope of line B, okay? And then compare them. If they're the same, that means the lines will be parallel. Same thing with this one. I want to know if these lines are perpendicular. Again, you're going to find the slope of line L. You're going to find the slope of line M, okay? And then you're going to compare them. If they are opposite reciprocal of each other, then that means the lines are perpendicular. Okay, now let's take a look at this example here. Now we're going to be using the slopes, okay, to classify quadrilaterals by sides. Well, this question is saying, show that PQRS is a parallelogram. I know that by definition, a parallelogram has 2 pairs of opposite, has 2 pairs of opposite sides that are parallel. Okay, let me rephrase that. Opposite sides of a parallelogram are parallel. Okay, so here in this case, to show that this parallelogram, to show that this quadrilateral is a parallelogram, I have to show that this side here, PQ, is parallel to QR, and I have to show that PQ over here, okay, is parallel to OR right here. This is S actually, SR, okay? So I need to show that those opposite sides are parallel. Okay, so I need to compare the slopes of PQ and SR, and I need to compare the slopes of PS and QR. Well, I can do it graphically here. See, from P to S, okay, from P to S, I go down 1, 2, 3, 4, and over 1, 2, and this slope is negative because it's going down. So this slope is minus 4 over 2, which is equal to negative 2. Now let's look at QR. So I start at Q, I go down 1, 2, 3, 4, and then I go over to the right 1, 2. So it's negative 4 over 2, which equals to negative 2. Okay, let's compare these two sides. Well, the slopes, I mean, the slope is negative 2, the slope is negative 2. Because these slopes are the same, that means PS is parallel to QR. Okay. Now let's look at PQ and SR. So PQ, I go down 1, 2, and then over 1, 2, 3, 4. So this is also negative because it's going down from left to right. So it's negative 2 over 4. Simplify that, it's going to be negative a half. SR, now let's see SR. I go 1, 2, and then 1, 2, 3, 4. So the slope of SR is negative 2 over 4, which equals to negative a half. So because these slopes are the same, it means that PQ is parallel to SR. Therefore, PQRS is a parallelogram. Okay? So again, you compare the sides, you find the slopes. If they're the same, then it's a parallelogram. All right, let's take a look at example 2. Now we want to find the coordinates of the missing vertex in each parallelogram. So I have these 3 vertices, okay, that I want to figure out the 4th one. Okay, so I want to figure out what S is. Okay, what's vertex S? Okay, where does that lie? Okay, so I need to figure that out. Okay. First thing you want to do is you want to graph the points that you have. Okay, you want to connect the lines. I know that PQ, see PQ is next to each other, PQ, and then QR is next to each other. So that's one of the sides. Okay. Now S is going to be somewhere over here. So I need to now come up with a point here for S that will make this line RS parallel to PQ. Okay, so first the thing we're going to do is we're going to find the slope of PQ. Okay, so let's count the slope of PQ. So from P to Q, okay, look, I start here, I go 1, 2, 3, 4. So I went up 4. Okay, so the rise was 4. And then I run 1. So the run is 1. Okay, now I am going to start at R. I'm going to start at R, and I'm going to count the same number of units, okay, going down and then going to the left. So from R, I'm going to go down 4 units. So I'm going to go 1, 2, 3, 4, and I'm going to run 1 unit. So I'm going to run to the left. So I'm kind of going on an opposite direction here, okay? This is going to be where point S will be, okay? Now let's figure out what the vertex is. Okay, so that's 1, 1, 2. So that's 1, negative 2. Okay, so the vertex for S is 1, negative 2. Okay. Now you connect the lines. So P goes to S, and S goes to R. And I drew the parallelogram there. Okay, and I found S. So this is the parallelogram. Now I want to verify that the slope of QR and PS are the same. So I want to use the slope formula and verify that the slope is the same. Okay, So now I'm going to do the slope of QR and the slope of PS. So QR, I have the points right here, so I put it in the formula. There we go. So Q and R, I want to find the slope. So I'm going to do 2 minus 4 over 2 minus a negative 2. I end up with negative 2 over 4, which is negative a half. Then I find the slope of PS. Okay, so P and S, which is the new point I found. Okay, so I do negative 2 minus 0 over 1 minus a negative 3. That's negative 2 over 4, which is equal to negative a half. So I just put a check and I confirm that those slopes are actually the same, which means they're parallel, and it confirms that this is a parallelogram. I would like for you to try the two problems that are underneath, okay? By finding the fourth vertices and vertex, and also verifying the answer, okay? Verifying that the slopes are the same using the slope formula. All right, so now I would like for you to try example 3 on your own, and this your turn on your own. Now we want to verify that this is a rectangle, okay? So in order for this to be a rectangle, these angles right here have to be right angles. So this has to be a right angle, this has to be a right angle, this has to be a right angle, right? And this has to be a right angle. Okay, how do I, okay, right angles, okay, are created by perpendicular lines. So how do I show, okay, that for example, this line here, right, is perpendicular to this line right here. So see right here, AB, I want to show that AB is perpendicular to CB right there. Well, if they're perpendicular, remember they have opposite reciprocal slope. So the idea here is that you're going to find the slope of the lines, and then you're going to compare it to see if they're opposite reciprocal. Then if they're opposite reciprocal, that means the lines are perpendicular. Okay? Then you have to do the same thing. You have to do the same thing for AD and DC. So we have to verify that these two lines are perpendicular. If they're perpendicular, then that means that this quadrilateral is a rectangle, okay? So the first thing you want to do here is you want to find the points, okay, the vertices, write them out over here, A, B, C, D, what are the vertices? And then you're going to find the slope of each line. So you're going to find the slope of AB, okay, using the slope formula. You're going to find the slope of AD using the slope formula. Then you're going to find the slope of DC and BC. And then you're going to compare the slopes, okay? These are some video resources that you can click and watch these videos to help you understand this material, okay? This work that you're doing here for this example 3, it's the same work you're going to do here on your turn, okay? And then we'll talk about it next in class.